Okay, so we have added this additive leads for the character movements. Now let's see how we can add uh, turn in place animations, which means like currently when our character is rotating, it doesn't actually showing any sort of animation, right? The turning animation. Instead, he's simply sliding through the ground, right? So this is not realistic enough. Instead of that, what we have to do is whenever the character is rotating to the left side, we are playing a turn in place left animation, and whenever the character is rotating to the right side, we are playing turn in place right animation. Right? So that is what we are going to achieve today. Okay, so as usual, let's start from the data structure onwards, and progressively let's apply the changes towards to the data tables, and then let's move to the ABP locomotion layer. So we can go to the movement data structure, which is SNM movement, and here we have set of stuff, right? For the idle breaks, cardinal direction animations, and the generic configurations. So similarly, we can add a new data structure called maybe SNM turn in place to implement our turn in place stuff. Right. So inside this movement, let's create a new data structure called SNM turn in place, and let's add a turn in place name called left 90 name sequence, and similarly right 90, and finally play rate. As the play rate, it should be a float, and as the default value, I'll set it as 1. Right? Okay. Then let's assign this data structure to as any movement data structure, and let's have a field called turn in place. The data structure should be turn in place, and I'll move it little bit up, maybe around here. Right, then we can go to the S movement group, which is its parent data structure. Save it, and we are good to go. And then we can go to this anim set. Now you can see this data structure has been broken. Because there are some structural changes. This is anim movement group. Right. Set anim movement. Yeah, I believe we have to reset the variable, but first, yeah, even here everything has been lost because we made some critical structural change to that data structure, but that would be fine. We can make a reassignment later on. So at the sanim set, I think we have to reset to boolean. Let's assign it back. Movement group. Right, now we are good to go. The data table level, now we have that record, but obviously all the stuffs had been cleaned. So we can reinitialize this stuff later on. But let's first see whether we can compile it properly. Yeah, now we can compile. And let's go to the data table level. Now we have a new record called turn in place for each record, right? Okay, now let's quickly reassign these values. So for idle, I think we can add mm unarmed idle ready, right? And for walk, unarmed idle break, sort of a thing. Yeah, idle break fidget, idle break scan. And for the turn in place, okay, I'll assign the turn in place values later on. But I think since this is a repetitive task, I'll pause the video for a bit and make the assignments. And in case if you lost the data at this data table, you have to do the data assignments again. But if you somehow manage to keep the data as it is, then no need for reassignment. So I'll pause the video real quick and make those values be assigned. Okay, so I reassigned all the lost values for walk movement and jog as well as crouch. So I think since we are keep losing these values multiple times, I think for safe side it would be nice if we export this stuff outside of Unreal Engine. Maybe we can export this as a JSON file or CSV file, but I think it would be nice if we export this as a JSON file, right? Right, so let's export it as a JSON file, maybe to desktop. I'll rename this as dt anim set, right? So in case if we lost our data table, then we can quickly reassign it by using that specific dump file, right? Okay, now let's collapse all of this stuff for a moment, right? Here also, and then our focus is basically assigning the turn in place values, right? Okay, so for walk, let's assign unarmed turn left 90, and for the right unarmed uh, turn right 90. And let's copy this entire turn in place configurations and paste it to the jog as well, because it's exactly same. But for crouch, actually we may need to use a different turn in place animation. So let's use unarmed crouch turn left 90 and here right 90. Save all, and let's export it back so we may not lost it again. So whenever you make a change to data table, if you want to persist it, for the safe side, let's simply just export it as a JSON, right? Okay, now we have those turn in place animations at our data table level. Now let's go to the ABP locomotion graph, not thread save functions, and set animation data. Right. Now what we can do. We quickly see. So here we set up the idle stuff, and I'll these are general idle stances. Here we set up the idle break stuff. Yeah, so I'll copy this L movement struct thing, paste it here, and let's promote this turn in place to a variable called turn in place. Right, and then let's move it to here, anim sequences, and I'll attach this pin. Let's hide the unconnected pins and collapse the node. I'll rename it as turn in place. Right, turn in place, maybe left and right. Okay, right, then what we can do, then let's go to the anim graph, and here inside the locomotion state machine, inside idle and idle sim, right, we have idle and idle break transition, and similarly let's add turning place related state and state transitions here, and we can later on populate this stuff. Okay, so first I'll add a state alias, right, and let's add a new state called turn in place rotation A, and this could be left rotation or sort of like that, and turn in place rotation B. Then finally turn in place recovered. The transition to here. After that, it will go to the idle state. Right. So as the state as the state aliases, idle rotation A, rotation no sorry idle break and turn in place recovery can be there, right? Okay, and then let's populate these state layers. So first I'll start with turn in place rotation A, and as usual let's add a sequence evaluator. This should be dynamic. This should be dynamic also. No need to expose as a pin, and it shouldn't loop. And yep, I think that's enough. And then the one become relevant. Let's set a new function and name it as setup turn in place anim layer. Right. So maybe I'll create a new category called turn in place layer, right? Uh, because we have set of anim node functions here as well. Maybe I don't need a separate group like that. I can reassign it back to the anim node functions level itself, right? Okay, and then I need sort of a initial variable called turn in place anim time. So I'll assign it as a float and create a new category called turning place, and initially I'll mark it as 0, and then let's get the node, convert to sequence evaluator, and let's set explicit time like this, right? Nothing, no need to return. Maybe we can keep the return node, that's fine. Then let's add a check node as well. Mark it as turn in place B, right? Because if I'm at the turn in place A, the turn in place B should not should mark as the opposite of turn in place B. I'll assign it to frame checks, mark it as boolean. Okay. Then let's get that variable, set it as not. Okay, right, so that's the first step, and then not. And then at the update we have to determine which turn in place animation that we are playing, right? So that's why I didn't add that sequence with initial blending logic here, because if we done that, that's just the initialization. But for each frame we have to check which direction that we are turning, and based on that we have to update the frame. So that's why we have to move that logic to this on update function. So let's create a new function, and I'll rename this as update turn in place. Okay, and I'll move it to here, right? Then let's set sequence with inertial blending and convert to sequence evaluator, and then now we have to determine what is the sequence we are playing, right? So that I'll create a helper function called select turn in place animation. This should be a pure function and thread safe, unless I need the help functions. Now let's get this data structure and split it, and as the input let's mark it as direction, which is a float, and then as the return value we are returning animation sequence. Return well, and we have to select the appropriate animation based on the direction. So we can check whether our direction is greater than 0. So if the direction is greater than 0, it is a positive value, which means we have to show the right rotation animation. If it is a negative value, then that's a left rotation, therefore we have to show the turn in place left animation. Okay, now let's go back to the update turn in place anim function, and let's get that helper function here and attach it to there. Right. Okay, and then most importantly we have to determine what is the turn in place rotation direction. So let's see how we can calculate it. Yeah. For now, let's mark it as a variable and keep it outside. And then we'll see how we can set its value. So for now, I'll mark it as turn in place rotation direction. Right. And then based on that, we get the animation and playing it. Okay. Right. And then I think we haven't set, yeah, we set this variable as 0 at the setup, and at the update we have to advance it based on the turn in place play rate and the delta time. So we can do that here to set the turn in place rotation direction. So I'll get the variable, split it, and as the play rate, let's multiply it with the context delta time, and let's add the turn in place, no, not this one, turn in place name time, right? And as the offset, let's add the previous turn in place anim time and reassign it to the turn in place anim time. Okay, then this anim time will be updated accordingly. And finally, we have to advance the time, otherwise the animation won't be played. So let's get the node, convert to sequence evaluator, set explicit time, which is this time, right? So the animation will be played frame by frame. Okay. Okay, this one is failing because why? Select turn in place is not thread safe animation. Okay, I'll delete it, compile it back, and let's reassign it, compile it back. Sorry, I haven't marked it as thread safe, right? Not the exec is true, but the thread safe is true. Okay, now that error has been gone. Okay, so make sure this select turn in place animation helper function is thread safe. Right. Then let's go outside. And as the state node function, we need on become relevant function. I'll call it as what? Setup turn in place rotation state layer, and I'll move it to state node functions. Okay, and then actually here now finally we can set this variable, which is turn in place rotation direction. But in order to capture the turn in place rotation direction properly, we need to determine what's our root offset, root your offset. Right, so for that as well, I'll create a new plot called root your offset. Is a float value. Compile, save all. And I just need its sign, right? And multiply it with by -1 to get the opposite sign, and assign it back to the rotation direction. Okay, now we have calculated this one, but we have to calculate this one to properly calculate this turn in place rotation direction. So I will move this turn in place rotation direction to the turn in place category, but I will keep this variable outside because then we know we have to set it back. Okay, so first state is now done, which is what turn in place rotation A. Right, and similarly we can set this turn in place rotation B as well. But I think the spellings are wrong. Turn in place rotation B. Okay, and it's exactly same as this, so therefore I will copy the sequence evaluator and paste it over here and attach it like this. And as the on become relevant function, you have to select that setup turn in place rotation state layer, right, which is this function. Because turn in place rotation A and turn in place rotation B are sort of like similar states, but the transition logics will be different. Okay, so now we have set up this one and this one, and let's go to the turn in place recovery, and there let's add a sequence player because we don't need to evaluate it frame by frame. Instead we can simply play the whatever the animation we have. Right, so there make sure to mark it as dynamic, and as the start position I think we can use that turn in place anim time. So turn in place anim time, and we don't need to loop the animation, right? So those are the possible configurations. And as the functions, let's use onUpdate function, and I'll create a new binding, and let's rename it as update turn in place recovery and move it to the node functions category, and let's set sequence with initial blending. Actually, it shouldn't be the sequence evaluator. Set sequence with this one, and as the node, let's convert to sequence player, return it, and as the sequence, you can use this exact same helper function, and as the direction, you can use turn in place rotation direction. Okay, this exact somewhat similar to this update turn in place anim layer. Yeah, we did the calculation and get the animation sequence to here and apply it with initial blending. But here actually we are calculating the turn in place anim time as well. And once the turn in place time has been calculated, at the recovery anim layer, we are simply use it to determine what's the recovery rotation animation that we should play. Okay, and then you add this layer, so I'll plug it to here, and as the state node functions, I think we need another binding, and I'll mark it as rename it as setup turn in place recovery state layer. Move it to there. Right, so here let's reset this turn in place. No, maybe we need a new variable to store that specific recovery rotation. Let me see. Yeah, we need a new variable. I'll call it as turn in place recovery direction and move it to here, and this should be simply taken as the turn in place rotation direction. Okay, let's compile, go back. Yeah, now all those 3 states has been done, and let's quickly set up the transitions so our state machine would be completed. So I'll start with this one, state alias to turn in place rotation A. There actually we have to get this root offset, so I don't need it sign. Instead I need just need to check its value, so I'll take the absolute value, and if it is greater than 50, then we have a possible transition, and the turn in place P should not be taken place. Sorry, turn in place B, not Boolean. And let's get the property access and the get movement component, bearing rotation to movement, this should also be not true. So if those three conditions satisfies, then we make a transition. Okay, that's the first logic, and I can copy the same thing and go back to this transition, right, and paste it back, and these two will remain same, but this one is different, right? Okay, now those transitions are done. Then finally we can go to this transition, recovery transition, right? So in the recovery, actually we have to be aware of the curve values as well. So there is a curve value called turn your weight at the turning animations. So if I show you this unarmed turn left animation as the reference, you can see by default Lyra provide these two curves for us. The first curve is remaining turn your, the second curve is turn your weight. So we can use these curve values to determine set of configurations. And I will use this turn your weight to determine that recovery transition. So let's go here and I'll get the curve value. Its name should be turn your weight. Turn your weight. And I think it would be nice if I promote this to a variable, so in case the curve name has been changed, I can quickly change this stuff. So I'll mark it as curve turn your weight and assign it to category called let's say, yeah, curves. So I'll get the curve value from this turn your weight curve, and let's check nearly equal to 0. Oh, we have an acceleration. We can make a possible transition. Okay, and the same transition applied to here. So instead of copy pasting it, what we can do is we can mark it as use shared, promote to use shared, and I'll give it a name called maybe stop turn in place. And now you can see that node has become red, which means we can use it in shared manner across the state machine. So if I select this transition and click this drop down, now you can see the shared transition rules. So I'll choose this one. So basically this is reference to the exact same transition rule. See? Okay. So only one more transition remain, which is this one. So I'll mark it as automatic rule based transition, because soon after we play the recovery turn in place animation, we can simply jump back to the idle state. Okay, right, and I think we can mark this as inertialization, right? And also this transition rule, mark it as inertialization, and this one also initialization. Okay, now our state machine is done, transitions are also done, also animation are set up at the data table as well. And then what is left is we have to play these transition logics based on this root to offset. But as I said before, we need to first properly calculate this root to offset, otherwise it may not playing properly. So maybe for testing we can set the root to offset as 60, and you can see it's playing sort of a turn in place animation, right? And if I mark it as negative 60, you can see it playing the turn in place for the other direction. But instead of hard coding it like this, we have to dynamically determine that root to offset value. So there are a set of calculations we need to be done, and let's do that in the second part of this turn in place tutorial. Otherwise this will be a bit long, right? So I'll continue in the part 2. Thank you.